Hello MyBase, welcome back to my channel. Today I will be presenting the Synthea Healthcare Graph Analytics System, a powerful way to analyze patient interactions, detect high-risk individuals, and simulate disease spread in a healthcare network using graph-based techniques. So without any further delay, let's dive in. First, we start by loading the Synthea dataset, which contains synthetic patient records and encounters. We use pandas to process and clean the data. The step leads patients and encounter data into pandas data frames. The patient's dataset contains details like names, birthdays, driving license, etc. The encounters dataset records patient interaction with healthcare providers. We print the first few rows to verify the data is loaded correctly. Now we convert this dataset into a graph network where nodes represent patients and edges represent encounters. This step transforms the raw tabular data into a graph using network X. Nodes represent patients and edges represent encounters between patients and healthcare providers. The final output confirms how many patients and encounters are in the graph. To better understand the patient interactions, let's visualize the healthcare graph using PyVis. This generates an interactive network visualization where each node represents a patient, edges represent encounters between them. Color coding is used to differentiate between patient nodes and encountered edges. Hovering over a node displays additional details like patient's name, age, gender. Now let's hover over a patient node to see their name and age. Now we use graph analytics to identify the most influential patient based on their connections using the PageRank algorithm. PageRank is a centrality algorithm used to measure the importance of nodes in a network. Patients with higher PageRank scores are more influential based on their number of connections. This step identifies the top 5 patients who have the highest influence in the healthcare network. Now, let's simulate a disease outbreak and observe how the infection spreads through patient encounters over time. This step models disease transmission using the healthcare graph. This simulation starts with 5 infected patients. Each infected patient has a 70% probability of spreading the infection to connected patients in each step. The infection spreads step by step, mimicking real-world disease transmission. The output prints the number of newly infected patients in each step. Here we can see how the infection spreads dynamically across the patient network. To make this analysis interactive, we have built a Streamlit dashboard where user can query patient risk levels and detect anomalies in real time. This command launches a Streamlit dashboard allowing user to enter a patient ID and view high-risk contacts. Run anomaly detection to find patients with suspiciously high encounters. Interactively explore patient networks. This dashboard is hosted online using Angork, so it can be accessed remotely. Now let's open the dashboard using Angork and explore high-risk patient queries interactively. In summary, this project allows us to analyze patient interaction using graph-based analytics, detect high-risk individuals using PageRank, simulate disease outbreaks within a hospital setting, deploy a real-time interactive dashboard for decision making. Future enhancement could include integrating real-time hospital data or using machine learning to predict patient risk more accurately. Thank you. I'm happy to take any questions. So if you have any questions, let me know in the comment section. Bye bye.